The topic what we are going to learn today is about close packed structures. In solids, already you know, in solids the particles are tightly packed. The constituent particles are closely packed, leaving minimum vacant space. The vacant space is called as void here. Void means empty space. The particles, now here today we are going to learn that only. So we consider that constituent particles as spheres like this. Consider the particle as a sphere. Now we are going to learn how these particles occupy, how it is closely packed in 1 dimension, 2 dimension and 3 dimension. Now we are going to learn about in 1 dimension, that is close packing in 1 dimension. In 1 dimension, there is only one possibility to arrange the spheres in only one direction. See, the spheres, the constituent particles as spheres. There is only one possibility only to arrange the spheres. In this arrangement, see, each sphere in contact with 2 neighboring spheres on either side. Each sphere with 2 neighboring spheres on either side. So here the coordination number is 2. What is meant by coordination number? The neighboring spheres which is surrounded the sphere, that is called as coordination number. This is 1 dimension. Now we are going to learn about close packing in 2 dimension. Here the spheres, see the constant particles as spheres in 2 dimension. 2 dimension means length and breadth. Okay, this is the first row. And second row exactly above the first row. Exactly above the first row, like this. They are arranged. Okay, length and breadth. A type. In this arrangement, each sphere is in contact with 4 of its neighbors. Now I will show. If you are taking this sphere, see, 1, 2, 3, 4. 1, 2, 3, 4. Each sphere contact with 4 of its neighbors. So, coordination number is 4. See now I have joined the center of the spheres. It is like a square. So it is called as square close packing in 2 dimension. Square close packing in 2 dimension. Now here this is the first type in 2 dimension. Now the second type in 2 dimension. The second row placed over the first row but in a staggered manner or fit in the depression of the first row. See, first row, okay, second row fit in the depression of the first row. This is A, this is B, then once more A. Okay, this is the AB type. Here, each sphere is in contact with 6 neighboring spheres. So here the coordination number is 2. 1, 2, 3, 4, 5, 6. One, two, three, 4, 5, 6. So the coordination number is 6. Each sphere is in contact with 6 of its neighbors and its coordination number is 6. If the center of the spheres is joined, I have joined, it looks like a hexagon. So it is called as hexagonal close packing in 2 dimension. The first one is square close packing and this one is hexagonal close packing. Here there are some voids. What is meant by void? Void means empty space between the particles, that is between the spheres. So here there are some voids in triangular shape in between this one. Voids in triangular shape like this. Triangle shape. So it is called as triangular voids. Triangular voids. The triangular voids are of 2 types here. In one row, the first row, apex of the triangle pointing upwards. Apex means this one. Apex of the triangle pointing upwards. Triangular voids, 2 type. First one, second one. The first one, apex of the triangle pointing upwards. Second one, the next row, this is in the first row. Then in the second row, next row, the apex of the triangle pointing downwards. So triangular voids in hexagonal close packing is of 2 type. In the first row, the apex pointing upwards. Second row, the apex pointing downwards. Now before going to the 3 dimension means length, breadth and height. So once more revise 1 dimension and 2 dimension. 1 dimension means there is only one possibility. But in 2 dimension there are 2 possibilities. The first one is square close packing. Coordination number is 4. Second one is hexagonal close packing. Coordination number is 6. If we are joining the center of the spheres, we are getting this one, hexagonal close packing. And here only triangular voids are seen that are of 2 type. One is the apex of the triangle pointing upwards. Next row, the apex of the triangle pointing downwards.